Hello everyone and welcome back to another video. Today we are going to be discussing limits. Now, this video is intended to be the first one you watch if you are just starting out on Calculus 1, and it will be going into exactly what a limit is, what it means, where they are defined, and all of that kind of stuff. Let's start by talking about functions. Now, I'm sure you've seen that a function of x, or f of x, is any system where you put in an x and you get a y out, or at least an output variable. Now, that input can be either a one-to-one relationship, meaning each input has exactly one output, or each input could have multiple outputs, or an input could actually not have an output at all, or the output is undefined, or it's infinity, or something like that. But what does that even mean? How can it be infinity, or how can it be undefined? What cases could we have where that could possibly be true? Well, first up, let's consider the function 1 over x. 1 over x. Okay, now you can probably understand how this function works. You put in 2, you get 1 over 2. You put in 13, you get 1 over 13. It's fairly simple to understand. Now, here's the kicker. What happens if you put in 0 for x? Okay, well, 1 over 0, that's not great. You can't divide by 0. What the heck? Well, why not? Why can't we even just say that it's just infinity? Because we can't even say that. It's undefined. Now, what does that mean? Well, let's look at the graph of 1 over x. So, based on this crude graph, we can see that as x is really, really close to 0, when it's a really small number on the positive side, it gets kind of bigger and bigger and bigger, and it seems like it would approach towards infinity, right? So maybe 1 over 0 is infinity. But the problem is, if you have a really small negative number that's really close to 0, then it gets closer and closer to negative infinity. And so it's kind of infinity and it's negative infinity at the same time, and you can't have that, so it's undefined. So 1 over 0 is undefined. It's no good. Anytime the denominator of a fraction is 0, you'll get an undefined value, even if it's 0 over 0. Because if you think about it, 0 over 0 is, well, 0 satisfies that, 1 satisfies that, 2 satisfies that. Any number times 0 is still 0. So 0 over 0 doesn't have any single possible value that it could output. This brings us to our major idea and what I'm actually here to talk to you about. This is the idea of a limit. If we take the limit, we write lim, as our variable x approaches, that's just this arrow, some value. In this case, we're talking about 0. Well, we have to consider it both from the positive direction and from the negative direction. As x approaches 0 from the positive direction, the output, or the function, or 1 over x, will approach positive infinity. And then if you approach it from the negative direction, it approaches negative infinity. And since these two limits are not equal, then the overall limit is undefined. Now, the thing with limits is that they're not always from both sides. We can take the limit from just one side, and that'll be by doing this notation. The limit as x approaches 0 negative, or x approaches 0 minus. This says, take the limit as x approaches 0, but only consider it when approaching from the negative direction. If we consider it in this case, then we can clearly see that as it approaches 0 from the negative direction, this will go to negative infinity. Now, this equals sign is a very loose equals. Nothing really equals infinity, but the limit tends to negative infinity, so we'll call it that. Now, what if instead we had limit as x approaches 0 positive? Well, in that case, we can see from the graph that it approaches positive infinity. Now, the problem is that 0 plus and 0 negative, those two limits don't approach the same thing, so the whole limit can't exist. This is an extremely important concept in calculus, so let me write it out for you. If, and only if, the limit as x approaches a being any real number, it doesn't matter what it is, from the negative direction of f of x is equal to the limit as x approaches that same number from the positive direction of f of x, then the limit as x approaches a of f of x will exist. Now, off the top of my head, I can't actually think of any examples other than the negative infinity and positive infinity type of graph where there'd be just a break other than a piecewise function, so now just smooth functions. But if you did have a graph that looks like this, say it comes like that, and then keeps going that way. Let's say this is at x equals 2 of some g of x, right? Then the limit as x approaches 2 of g of x, it doesn't exist. As we can see, the limit as it approaches from the negative direction and from the positive direction don't converge to the same value. Wait a second. What do I mean by converge? What does converge mean? Before, I just used an equal sign. I mean, if it just equals it, then why is it converging? That seems like an awfully awkward word choice. Well, I did say it was a bit of a loosely placed equal sign because it's not equal, really. It's convergent. Now, what that means is that if you get infinitely close to something, then mathematicians consider it at that thing. An example of this that you may have already seen is an infinite geometric series. Take the series 1/2 plus 1/4 plus 1/8 plus 1/16, on and on and on. Now you may think, well, every number in this list will be greater than 0, and since you keep adding them, then maybe this approaches infinity. Well, it doesn't. It actually converges to a single value. This whole sum, this infinite sum, converges to exactly 1. Now, there's plenty of geometric proofs for this, but the idea is that an infinite sum can in fact result in a finite number. And by the same principle, an infinitely small distance is essentially zero distance because it converges to 0. If you're still a little confused, let me give you a more grounded example. There is this extremely famous paradox of Achilles and the tortoise. Consider a race, right? We've got 2 lanes. This is lane 1, here's lane 2, this is the finish line. If we have a tortoise here, call it T, and then Achilles here. Now, Achilles, he is an excellent athlete and certainly faster than a tortoise. If they start the race, but the turtle has a head start, then by the time that Achilles reaches the point where the tortoise was, the tortoise will have moved some amount. And by the time Achilles reaches that new spot, the tortoise will have moved some amount. And the paradox comes in that is somewhat true in a logical sense. I mean, every time that Achilles moves some distance, the tortoise will have moved some distance as well. But the problem is, and we know this, that if Achilles is faster than a tortoise, Achilles is going to win this race, and the tortoise is only going to be like back here. So what gives? How can he overtake it if it seems like an infinitely long journey? I mean, clearly it's not, but the logic behind this seems so sound. And the problem with the thinking of the ancient Greeks was that they didn't know about limits. They knew that Achilles would overtake the tortoise, and that's because at a certain point, the distance that the tortoise will have traveled is effectively convergent to 0. And so the tortoise doesn't move at all, and Achilles will overtake the tortoise. That is the idea of a limit. Diminishing returns, if you want to call it that, but any idea of how a number that's infinitely close to something is that something. If x is 1.9999999, then it's not 2, but if it's an infinite amount of 9s, then it is. I've had a very mixed bag when teaching limits. Some people pick it up immediately and understand it fully, and some people, it's harder for them to wrap their brain around it because, I mean, it's a hard concept. So if you're still confused, don't worry. There will be more videos that I will be making in the future, and there's tons of other resources out there that you can look to if you're still confused. But hopefully this video helps you understand it, and as always, thank you so much for watching.